Hello everybody, welcome back in our computer science as well as informatics practices class. As you know, we are working on the chapter number system, and in the previous classes we discussed about how to convert a decimal number into its binary equivalent, into its octal equivalent and into its hexadecimal equivalent. Now in today's class we will discuss about how to convert a binary or octal or hexadecimal number system's digit into its decimal number system equivalent. Clear? So very first our first topic is binary to decimal, right? Dear student, as you know, computer system is having four different devices: input device, processing device, output device and the auxiliary device, or we can say storage device. So these four devices are there inside a computer system, and we know that the processing device of our computer that contain a processor, RAM, ROM, that motherboard, the processing device of our computer, it works on machine language only, or we can say the processing device works on binary language only. Binary language means what? Binary language means it is a possibility of only two symbols. The first one is 0 and the second one is 1. Clear? So processing device works on binary language, and here once we supply an equation to the processing device of our PC, the processing device executes, or we can say calculate the equation and find out the result in binary format only, right? So here the binary digit is coming out from the processing device towards the output device. Just see this one. If we supply a calculation, that is 5 plus 2, computer converts 5 into 101, converts 2 into 010 in the binary form, and this binary equation is going to solve at here at the processing device portion. Right? Now the result should be in binary language only. Result is 111, it is there in binary language, and this result travels from the processing device to the output device. Clear? Now the binary digit approaches at output device. Now it is the responsibility of each and every output devices that they converts this binary language, converts this binary number into user's readable format. User's readable means either English language or we can say decimal number system. So there are a converter in each and every output device that converts the binary language input into its decimal counterpart, right? So here the output device, it shows decimal number only, or we can say decimal number, or we can say user readable formation only, right? So here the output device, it is going to convert the binary input into its decimal equivalent. Now what is the process to convert the binary into decimal? This is our today's topic. It is how to convert binary into decimal. Clear? Now just take an example. Suppose a binary digit 1011. This is the binary digit, and if we want to convert it into decimal number, it looks like this one only. 1011, combination of 0 and 1, combination of bits. Bits is known as binary digits, right? So here this type of question you may see in the coming question papers, right? So this is our today's class, how to convert a binary number into decimal number. Clear? Now just understand what is the process of converting a binary number into its decimal counterpart, right? Suppose this is a binary number 1011. It is a binary number and we should convert it into decimal. Now what is the process? The process is, the method is, very first write the binary number like this. Here it is binary digit. Just prepare one table, binary digit, and I am going to put the digit in each and every column. 1, then here it is 0, then again 1, then again 1, right? looks like this one. Binary digit 1, then 0, then 1, then 1. Then here at the downside in the next row, I just write power of 2. Power of 2 means it is a binary number. So we just take power of this binary base value 2. So just start from the right hand side. From the right hand side in the very first box, just write 2 raised to power 0. Then here 2 raised to power 1. Then 2 raised to power 2. Then at the last 2 raised to power 3. Just come towards the right hand side and put the increasing power of the base value 2 from right to left. 2 raised to 0, then 2 raised to 1, then 2, then 3. Clear? So, the very first step, we just convert it into like this one. Done? Now, what is the result of different power of 2? Just check it out here from this table. 2 raised to power 0, it means 1. Clear? 2 raised to power 1 means what? It is 2. 2 raised to power 2. 2 raised to power 2 means we can solve it like this. 2 into 2, it is 4. So 2 raised to power 2, or we can say square of 2, it is 4. 2 raised to power 3, result is 8. 2 raised to power 4, it is 16. 2 raised to power 5, it is 32. Right? On the other side, if you want to know what is the decreasing power of 2, 2 raised to power minus 1, it is 0.5. 2 raised to power minus 2, it is 0.25. 2 raised to power minus 3, it is 0.125. And at the last 2 raised to power minus 4, it is 0.0625. Here it is the different power of 2. Right? Now, just convert this one. Now we start from the leftmost part. Here it is 1 into 2 raised to power 3 plus we are going to add these different columns value with each other. 1 into 2 raised to power 3, I write like this one, then plus 0 into 2 raised to power 2 plus in the next column 1 into 2 raised to power 1, then plus here it is 1 into 2 raised to power 0. Now just solve it out. 2 raised to power 3. What is the value? 2 raised to power 3, it is 8. So I just write 8 over here plus 2 into 2 raised to power 2. 0 into 2 raised to power 2. 0 means the overall calculation, the overall equation, it goes 0. 1 into 2, it is 2. Then here it is 1. Now just add these one. 8 plus 2, 10 plus 1, 11. The result, it is 11 in the decimal number format. Clear all? So this is the process by which we can convert a binary number into its decimal equivalent. Now just take one more example. We are going to take a fractional binary digit and try to find out what is the result of that particular binary digit, right? Here, now the next example, our digit is 10111.101. This is our binary digit and we have to convert it into decimal value. Clear? Now the another method, this is a tabular method. If we solve this one in another style, just take one, this digit, we are going to expand the binary digit and we just put a small gap in between these digits, just like this one, 1 plus, here it is 0, then plus some gap is there, then 1 plus, then again 1 plus, then 1. Right? Just apply a gap in between each and every digit. Then here I am going to put this decimal point. Right? This is the decimal point. Then 1. I just put 1 over here. Then space 0. Then space 1. Clear? So the digit is going, I am going to expand the digit here. Now, just start from the decimal part. Here it is the decimal point of the digit. So just start from here and we move towards this side. This one into 2 raised to power 0, into 2 raised to power 1, into 2 raised to power 2, into 2 raised to power 3, and here 2 raised to power 4. Right? Start from the decimal part, increasing power of 2, just check it out, 0, 2 raised to power 0, 2 raised to power 1, then 2, then 3, then 4. Clear? Now come towards the fractional part. Here I am going to multiply the digit from 2 raised to power minus 1. Clear? You start from the decimal part, and if you move towards this angle, 2 raised to power minus 1, here 2 raised to power minus 2, and at the last 2 raised to power minus 3. Just arrange the digit into this style. Clear? Now just come here. What is the result of this one? It is 1, then plus 2 raised to power 1, 2, 2 into 1, it is 2. Then plus 2 raised to power 2 means 4, 4 into 1, it is 4. Just check it out. Now 0 into 2 raised to power 3, it is 0. 2 raised to power 4, what is the value? 16. 16 into 1, it is 16. So 16 plus 0 plus 4 plus 2 plus 1, right? Now come at this side, this decimal part. What is the result of this one? 2 raised to power minus 1, it is 0.5. Just put it in the small bracket. 0 into this one, so here the result is 0. Then plus 1 into 2 raised to power minus 3, it is 0.125. Just put this 0.125 over here. Here you have to add this part separately and the fractional part separately. Done? Just add this one. 16 plus 4, it is 20. 20 plus 2, it is 22. 22 plus 1, it is 23 now. 23 point. Now just add these digits with each other. 0.5, 0.125. So it is 0.625. Right? 0.5 plus 0.125 means 0.625. Now this is the decimal equivalent of the particular binary number. Clear? I hope the concept is clear in front of you. Thank you. Now our second step is we are going to convert an octal number system's digit into its decimal counterpart. As you know, octal number system starts from 0 and ends at 7. Total 8 different fundamental digits are there in octal number system, and the base value of octal number, it is 8. So very first we should know the different power of 8. 8 raised to power 0, it is 1 only. Then 8 raised to power 1, it is 8. 8 square, it is 64. 8 cube, it is 512. And the last one, 8 raised to power 4, it is 4096. Clear? If we talk about the negative value of 8, 8 raised to power minus 1, it is 0.125. 8 raised to power minus 2, it is 0.015, and so on. Right? So just take an example. We are going to convert an octal number 174.2. It is an octal number, and we are going to convert it into decimal. The process is same, the method is same, the calculation is same, just we did in the binary into decimal formation. Right? So very first we are going to write this digit with some gap. Here it is 1. Then after some gap I am going to write it 7. Then again the gap is there, it is 4. Then point, here it is 2. Right? Just expand the digit and put some spaces, put some gap in each and every digit. Now just hold the decimal part, it is the decimal point, hold it and start the increasing power of 8 from the rightmost corner from the decimal point towards the leftmost side. So 4 into, it is 8 raised to power 0, 7 into 8 raised to power 1, then just use addition symbol, plus symbol in between all this part. Here 1 into 8 raised to power 2. Right? Start from the rightmost part. 4 into 8 raised to power 0, 7 into 8 raised to power 1, 1 into 8 raised to power 2. Right? Now point 2. Here we use the negative power of 8. So the formation, the very first step, it looks like this one. Clear? Now just come to the second step. It is the first step. Come to the second step. 1 into 8 square, what is there? 8 raised to power 2, it is 64. So I just write 64 over here. Then plus 7 into 8 raised to power 1, it is 8. Then plus 4 into 1, 0.2 into 8 raised to power minus 1, it is 0.125. Just put it inside a bracket. Fractional part we should put inside the bracket only. Now The third step, it is 64 plus 8 7 ja, it is 56. Then plus 4 into 1, it is 4. Then here point decimal part 2 into 0.125, it is 0.25. Now just solve this equation. 64, 56, then 4. It is 6124.25. Here it is the overall result if we convert this octal number into decimal part. Clear? The method is same, just expand the digit, hold the decimal point, and from the rightmost corner, rightmost part of the decimal, we just going to multiply increasing power. 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. These are the increasing power of 8. And from the leftmost part of this decimal, we just going to multiply the decreasing power of 8. 8 raised to power minus 1, then 8 raised to power minus 2, 8 raised to power minus 3, and so on. Right? It is the process by which we can convert an octal number into decimal. Clear? Yes. Now our next topic, it is related with how we can convert a hexadecimal number system's value into its decimal equivalent, right? As you know, in hexadecimal number system, there are total 16 different fundamental digits, right? It starts from 0, 0, 1, 2 till 9. It is just like the decimal number system's digit only, 0 to 9. And after 9, in hexadecimal number system, A will be there. A, B, C, D, E, F. The last point is F. The starting point is 0. Clear? Now, A stands for, it is 10. B stands for 11. Then C, it is 12. And the last one, F, it is equivalent to 15. Clear? Now, we just take an example to convert a hexadecimal value. Suppose a hexadecimal value 1AF. It is there, and we have to convert it into its decimal equivalent. The process is same, student. The method is same. If we want to convert binary into decimal, same method. Octal into decimal, the method is also same. And the last one, hexadecimal to decimal, same method is applicable. Just expand the given digit and multiply the digit. Starts from right to left into the increasing power of the base value, right? Here, what is the base value of hexadecimal number? The base value of a hexadecimal number, it is 16, right? So very first, we are going to expand the digit like this one. A, put some gap, 1, then put some gap, A, then again a gap is there, then here it is F, 1AF. Start from the rightmost part. Here, just multiply it with 16 raised to 0. A multiply by 16 raised to 1. 1 multiply by 16 raised to 0. Then use plus symbol in between these three parts. Clear? So it is the very first step. What will be there in the next step? It is 1 into 16 raised to power 2 A. A should be converted into its digits equivalent. A. It is 10. So instead of A, I am going to write 10. Then instead of F, I am going to write 15. Now the equation looks like this one. Clear? Now just solve the equation. 1 into 16 raised to 2. Here on the next part of the board, I just wrote the power of 16. 16 raised to 0, it is 1. 16 power 1, it is 16, then 16 square 256 and so on. And here you can see the negative power of 16 also. Right? You have to draw this table into your notebook. Clear? Now, 1 into 16 raised to power 2, 16 square, it is 256. Then plus 10 into 16 raised to power 1, 10 into 16 means what? It is 160. Then 15 into 16 raised to power 0 means it is 1. Now 1 is multiplied by 15. The result is 15 only. Clear? Now the overall result, if we are going to add these three parts, the overall result is, it is 431 in its decimal equivalent. So here it is the answer. Clear? I hope the whole topic is understandable by you. Thank you.